Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Firstly, let me say thank you so much. I think Saturday evening, just after 7, I think, if I'm correct, if I can remember vaguely correct. The number, we reached the 500 number. So thank you so much for that. I really appreciate it. I had a nice ice cold beer when I saw that number, and then followed by a nice glass of red wine. So yes, yeah, that was a very nice surprise. I really appreciate your support. Now half of the target is there, the 500 mark. Now the next 500. So basically the counter starts now at 0, and we have to go to the 1,000. So again, please, yeah, if you haven't done so already, please smash those buttons, press those buttons. Let's get that number up. Now the next target is 1,000. Let's see if we can get to 1,000 before the end of the year or beginning December. So let's put that out there. So if you enjoy my videos, you find value out of it, please do me a favor. Please press those buttons. Let's get those numbers up. So as I said, I'm busy just following up on. I'm busy following up on some of the comments that I received over the last several weeks. Just responding to those comments, making sure that I respond to everybody. I received 1 or 2 new comments, but we'll get to that. So one of the comments was the issue of the snow cover that we've done. Another comment was about the issue of surface and groundwater, and that we've done. And I've received a wonderful suggestion that I will do just to add to this. And then I received a question from a local business owner in a Langebaan area about the change dynamics of the town itself, and that's why I've did these 2 videos. The one is Langebaan working on a median image, and the one is on a mean image, just to showcase the difference between doing a time lapse using median and a time lapse doing mean images. So that we've done. I've also received some questions regarding sea temperatures, temperature of oceans, salinity of oceans, to see whether there's any warming taking place or whatever the case might be. So this will be a video that focuses on seawater temperatures, salinity, and velocity. So that's what I'm going to focus this particular video on. Okay, so let's have a look at the data set before I go anywhere. It is this data set. So there's in fact 3 of them. So let's go quickly to data sets. I'm going to search for it, paste. Let's go there. So there's 3 of them. It's called the hybrid coordinate ocean model. And there's actually 3 of them, 4 of them in fact. There's one that focuses like this one, that focus on water temperature and salinity. And you see they also focus on the different depths. So a depth at 0 meters, and then goes down to a depth of 1 kilometer. That's interesting. In fact, it goes down to 5,000 meters. These are all estimates. Yeah, minimum number, maximum number is just estimates. Okay, so the actual numbers within that. Okay, so this is actually quite big. And then also, if I go to just search for the parent data set, because that's a sub data set. So if we go to the parent data set, you'll find there's a couple of them. There's the water temperature salinity, there's a sea surface elevation, and there's a water velocity. Okay, so the sea surface elevation would basically measures, it's a nice thing to it, will measure the surface elevation anomaly, meaning this sort of measures where the sea surface temperatures are on the increase or on the decrease. So that's what this measures. And then the one is the velocity. This one here. You see, they're all from the same 1992 to 2024. And this is velocity meter second. This is eastward sea water velocity and the northward. So it's two directions at a depth of 0, and then it also goes down to 5,000. So this is velocity. So I would imagine that is the speed of the waves, so the movement of the sea type of thing. So there's actually, as I said, within this parent data set, there's 4 sub data sets, one water and or four variables or bands. One is water temperature and salinity, one is elevation, and one is velocity. So these are actually quite nice data sets. They're very nice data sets. Couple of issues, or two in the main issues. It's daily data, which means that this is a hell of a lot of information. So this is daily data, so time series from the beginning to the end is out. You can't do time series. You'll have to, if you want to do time series, have it for a year period, because a year is 365 data points because it's daily data. So time series work is a bit more complex, and then again, the resolution is terrible. 9,000 meters, but I would think that it would be sufficient in terms of that. Point is that water temperatures won't differ that much within a large range. So water temperature would be fairly similar in a wide radius or in a wide area. So therefore, you could have this type of resolution. It won't. You're not going to miss the details, the finite details, the granular details. You're not going to miss. That's the point that I want to make. Okay, so I've taken this and let's then apply it. And I said, okay, let's apply it for the South African coastline. So this is the South African coastline, and I just basically arbitrarily draw this coastline in terms of where South Africa starts. It starts at Oranjemund, and where it ends here by Cozy Bay. I took it a little bit up, but yeah, it ends here at Cozy Bay. And then I just draw it via using, in fact, I did this in QGIS. So I draw that in QGIS. I found it easier to do in QGIS than do this in Earth Engine. So I did this in QGIS, and then I saved it as a shapefile, and I brought it in as an asset. I brought it in as an asset using the new, etc., etc. Okay, so I did this. And now obviously it overlays with the land because I can't draw it exactly. You actually should get a layer, South African boundary layers, and subtract the two, and then you'll get a more precise. The width of this image, it's just freehand. So there's no science, nothing particular. You could draw it narrower, you could draw it wider. That's actually up to you. In fact, in hindsight, I should have drawn this a little bit wider. It's a bit narrow. But anyway, the idea was to see what we can find out, or what we can learn from this particular data sets, or a series of data sets. Okay, so I hypothetically draw this shape line, or created this coastal shape file within QGIS. And then I just, as I said, brought it in, put it in there as my region of interest. And then I went the old-fashioned route. I didn't use the loop function. I went the old-fashioned function here. As I said, the problem with this data set is daily data, so it becomes a little bit more tricky. And that's why I decided to use the old-fashioned way, copy and paste, and just change the dates. So there's my data set for 1993. That's the data set. There's my date. And then I've got a fault on my band. And then the band has scale values. If you look there, it's got a scale and an offset. So I compensate for the scale and the offset. Scale is multiplied, offset is. And you do that for all. So I've done an image for 1993. I've done an image for 2000, so that's 7 years. And then one for 2010, which is 10 years, and one for 2020, another 10 years, and then the latest for 2024. So it's 1, 2, 3, 4, 5. So there's 5 images. I'm not going to do year-on-year images because I don't think there would be massive differences within a year period. I very much doubt that. So that's how I've just made it in 10-year cycles. Made it in 10-year cycles. Okay, so then because it's a daily data, moving it to here, I use the median reducer, clip it to my region of interest. So again, nothing there. There's my visualization parameter. So minimum temperatures is 12 and maximum temperatures is 25. Blue, green, white, and orange. So blue is cold, red is hot. And then I just add them to my layers, and there they are. So there's median daily. Okay, this daily data there. So it's median daily seawater temperatures in 93 up to median daily median seawater temperatures in 2024, and they are all in Celsius. So I don't have to convert it from Kelvin to Celsius. If you want the data in Kelvin, then you must just add to 273 to that, and that will give you then then that will give you the Kelvin. So if you want to work in Kelvin, so you can see basically. So this is for. Let me just go. You see, it's loading. It's struggling to load because it's daily data. To calculate the median of the daily is quite a lot, and that's why it's struggling. So there is 1993. Okay, so let's have a look at 1993. So this is red, this is warm, and then it becomes cold. So this is the warm Indian Ocean that goes up and down this coast, because India is, there's India, so this is the Indian Ocean. It goes along the eastern coast of South Africa. And this is also the equator is up to here, and this is the cold side of the ocean, which is the Atlantic Sea. You see, there's the Atlantic, which is the cold. So the warm water is coming from the equator. It's coming down here. It's going to the Antarctica, and the cold water is coming from Antarctica this side, going up. So that's the flow of the oceans. So firstly, I wanted to find out what is the difference in temperature between this, call it the eastern border of South Africa and the western border of South Africa, because this would be where it's the hottest and this is where it's the coldest. You can see it sort of meet here somewhere in the middle. It meets here somewhere in the middle and stuff. So let's have a look. So yeah, so there they are. So let's quickly go into 2024 and see if there's any difference while that is loading. And again, it will take time because it's daily data. So it's running through 365 images now. And that's why it's taking a bit of time. So let's use the inspector. So let's go to this particular area here. And you'll see there the temperature in 93 was 24.3. 7 years later is 24.4. 10 years later is 25.3. 10 years later is 25.2. And 2024 is 26.4. So it basically increased, decreased, but from 93 to 2020, that's a 1%, 1 degree increase in, 10, 20, 17 years. So that's, but there's quite a bit of an increase from 25 to 26, 1.2 degree increase, which is quite a lot. I think if you look at it historically. And stuff. So, but anyway, the point is, let's have a look. It's it's 26 point, it's 24, let's say average 25. Okay, if I would do that, this point here, the average temperature is 25. Let's have a look at it in the most western side. That's about 15, 15. Let's have a look at it. So 15.6, that's a decrease, 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 and a bit of an increase. Anyway, let's average the 15. So that's, what's it, 25, that's a 10-degree difference in water temperature between the most western point of South Africa and the most eastern point of South Africa, western border of South Africa and eastern border of South Africa. 10-degree difference. That's, I think, given it's only 14 or 15 or 20 degrees, that's a massive, that's quite a lot. That's almost a, what's it, a 50 odd percent difference and stuff. So that's quite a big change. Now, what's interesting here is that um, it's actually this side, it's getting colder. So the cold water is getting colder, and just hold on quickly. Sorry, just had to sneeze quickly. So that's something also interesting, is that the warm water is getting warmer and the cold water is getting colder. Because if you remember, see here, the 15, it's going down. Okay, there's been a slight increase in the last couple of years, but it's still less than what it was in 1993. So although it is decreased and the decrease have stopped, it's still less. So the cold water is definitely getting colder. That seems to be, yeah. But if you go back to the hot water or the warm waters, this is actually increasing. You can see that 24 to 26. So the cold water is getting colder and the warm water is getting warmer. So the difference between the water at seawater temperatures at our eastern side and western side, the difference between them is getting bigger and bigger and bigger. And that I found quite interesting. That's something I didn't know, and I think that's quite interesting now. Um, Water getting warmer and water getting colder would have some significant impact on tourism, because nobody likes to swim in cold water. You rather want to swim in warm water. So that's one thing, and obviously fishing. Most of South Africa's fishing is in cold water. So water getting colder is actually good for the fishing industry and vice versa. So there could be some significant impacts of this change in the water temperature, and specifically the dynamics between the east coast and the west coast. The water on the east coast seems to be getting is at least 10 degrees warmer, and it's getting warmer, whereas the water on the east coast are 10 degrees lower, and it's getting colder. 10 degrees colder, and it's getting colder. So that's quite interesting. And somewhere in the middle is, you see there's the 19, so somewhere in the middle is where the two meets. And you can see that white is here. And stuff. So that I found interesting. And then I thought, okay, given that, is there seasonal differences between the temperatures? Meaning, I would assume that winters would be colder and summers would be hotter, meaning the temperatures, the atmospheric temperatures will play an important role in it. So then I created for 1993 a summer and a winter image. So summer is January, February, March. Winter is May, June, and July. May is actually, this actually should be 6 to 8. That's the coldest period, just to have it correct. And then for 2023, I didn't put 2024 because we don't have this for 2020. Yeah, we would. So I actually should make this 2024. Anyway, so I created a summer and a winter image for 1993, and a summer and a winter image for 2023, and I compared it. So let's have a look. So let's go back to our eastern shores, eastern coastline. Let's have a look and see what happens there. So you'll see there is the winter temperature in 1993 and the winter temperature in 2023. So the winter temperature is getting colder. See that? The winter temperature is getting colder. and the summer temperature. Well, let me put it this way. The winter temperature is colder than the summer temperature. In 1993, uh, and, and the and the summer temperature is also colder. So 1990 to 2023, both temperatures were colder. So that's 926. Actually, should take 2024. But that's not the point. The point is winter to winter, summer to summer. So winter is less than summer by at least 3 degrees. So that's quite a lot. And here, winter is less than summer, but also maybe about 4 degrees. So that's the point that I want to make, is that in the eastern side, the summer temperatures is much hotter than the winter temperatures by at least 3 degrees. You can see there's summer, winter, basic 24, and this is basically 27. Winter, this is basically 24, and this is 28. So there's quite a lot of difference between the winter temperature and the summer temperature. At least 3 to 4 degrees, with the winter being colder than the summer. Okay, so let's look at it from the western side. Let's have a look and see what's happening there. So we're just waiting for the winter. And the same, the winter 15, summer 17, winter 13, and summer 17. So again, about 3 to 4 degree difference between the winter and the summer. So when you want to swim in the west coast, western coast, you only want to swim in the summer. You don't want to swim in the winter. It's very cold. In the eastern side, you'll swim both sides, but the hot water is much hotter, closer to about 30 degrees. That's quite hot in the summer versus the winter. So it does take from the ambient, from the atmosphere, it does take. So that is temperatures. And we can play around now with temperatures at various distances, various locations, to see what has happened with those temperatures over time. And we can actually see whether the seasons have changed, whether the seasons have changed. So that is temperature. So that's interesting. I did the same for salination, meaning the saltiness of the seas, so salinity, and that is measured by practical salinity units at a depth. Practical salinity C. Remember, by the way, this is at 0 degrees, ne? 0 meters. At 0 meters. So we could do the temperature at let's say 1,000 meters, but who swims at 1,000 meters? So it's probably 2 meters or 4 meters to see what that numbers look like. Anyway, you can play around with this. And then the salinity, and again, what we see here, if we let's go to inspector here by the eastern side, salinity is 35, 35. And that's by roughly the same, 35, 35, 35. It changes here and there, but you can see it's very stable. So it hasn't become more salty or less salty, 35. Let's winter and summer, roughly the same. With that 35, let's go ahead to the eastern side. And you see it's also 35. So the salt level, the salinity levels between the warm Indian Ocean here at the eastern side and the cold Atlantic Ocean here and the western side is pretty much identical. Pretty much identical. Very little seasonal influences, etc., etc. Whether it's cold or hot, salinity levels are pretty much the same. So that I think is also interesting. And then let's have a velocity. This is our velocity. Let's see, go. Remember this again at 0 level, so maybe that's the reason why. We'll have to go maybe 2 meters to see what's happening there. And let's have a look at the velocity. We go here now, eastern side. Velocity is 19 meters per second. And it has stayed roughly the same. Very little changes. And the difference between winter and summer is also negligible, almost irrelevant. So roughly about high 19s, almost 20, rounded. So let's have a look at the velocity at the western side. also roughly the same. So the velocity and the salinity is what is there? There's some big difference here. What's happening here? Let's have a look and see what's happening there. No, it's still the same. It's just what did I do? We did the scaling is very, very small, so that's why it's going to be like that. You see, the velocity was actually should have taken it a bit further. Anyway, it's running through daily stuff, so that's why it's taking long. But they're all about the 19s. I think here it's most probably in the margins. But anyway, so the point here seems to be, if you look at these three data sets, the point is that there's big differences in temperature, sea level temperature between the eastern side and the western side. So that's sort of a given, huge differences. And the differences are getting bigger in that the warmer temperature, warmer side, the eastern side is getting warmer, and the colder side, the Atlantic side or the western side is getting colder. So the warm water is getting warmer, the cold water is getting colder. So that difference is increasing. However, the salinity and the velocity is roughly equal between the two sides, and um, uh, and it hasn't changed much over time. So take that for what it's worth. Whether you think it's interesting or not. As I said, we actually should made it. Let's have a look. I just want to see if I do this. See what is that? Let's zoom in. I just want to see if I go close to the shore. So let's go close to the shore. So that's 19. We go further out. 19. But you can see the velocity here further away is close. So that makes sense. So if we go, we zoom in. So the salinity level close to the shore. Oops, sorry. Salinity level close to the shore. And then we look at 35 and we look at the salinity level further away from the shore. See if there's a difference. No, not much. Temperature wise, let's have a look and see. Let's have a look and see there. Temperatures there. Mask, sorry. Okay. Make sure that there's a data 23, 26. Let's go it further back. No, not much of a difference. Okay, so it's not much of a difference. Now, I just thought that maybe it's important to increase the width of my coastline so that we can measure the, the temperature close to the coast versus further away. But again, it doesn't seem, well, in my radius, most probably will have to go quite a bit further. And then, as I said, we can do this for any other depth. So whether we're going to go 50 meters, 60 meters, it depends what you want to look at. Depends what you want to look at. That's something that one can do as well. Anyway, the idea is just to show you that these data sets are available, and what these data sets are presenting, or what information that you can derive from these data sets. And as I said, it gives you quite a nice overview or picture of what's happening with your ocean, specifically close to your coast, your coastline ocean, in terms of temperatures, in terms of salinity, and in terms of velocity. So that was just quickly, yeah, three nice little images or three data sets that I wanted to present based on some comments that I received. So certainly something that I'm going to work on further, because as I said, I think there's some useful information that one can generate from this. Specific with this whole idea that, yeah, the water temperatures are rising and waters are getting warmer and all this mumbo jumbo. Anyway, don't want to go into that debate. But anyway, here's some stats and facts that either, yeah, supports what you want to have or not. That's depending on your position. Anyway, let me park it for there. Um, let me stop there, and we will continue with some of the other comments. And then I've got one or two interesting things that I want to do. As soon as I'm done with all my comments, then I've got something lined up which I think you'll find very interesting, hopefully. Hopefully. Okay, so with that said, let me stop there for now. Thanks again for your support. I really appreciate us getting the 500. It feels like a milestone. I never ever in my wildest dreams thought that we'll get to 500. And now we're chasing the 1,000. Huh? Now we're chasing the 1,000. Let's get it up, man. Let's. Arnold says they're gonna what said that make my day. Yeah. So please, I count on your support. With that said, I'll see you on the other side.